Hi everybody, and welcome to the introduction to drawing and using SketchUcam. I have SketchUp 2015 open, and as you can see I have the SketchUcam toolbar and the Flatbones toolbar present on my ribbons. I've drawn a 100 by 100 millimeter square, and I'm going to briefly show you various cut options. You will notice that this drawing is flat and level with the XY plane. If you do your drawing any other way, it will not work with SketchUcam. SketchUcam is designed around flat drawings rather than three-dimensional drawings. There are a number of plugins free on the web to help you convert three-dimensional drawings into projected flat part segments, and you can use those or do it manually as you choose. I'm just going to do some simple things on this drawing to illustrate the various tools available. To cut this plain square out of a sheet of material, I have offset the corner from the 0, position by 10 millimeters. The first thing one should do is make sure that one has the correct bit diameter set. If you create your cut lines with the wrong bit diameter, your parts will come out the wrong size, because the cut lines are offset by half the bit diameter from the existing drawing parts. I'm going to stick with the 3mm bit on 6mm material. Feed rates as for cutting foam. Overhead gantry is selected. That affects the clockwise or counterclockwise direction of tools like the inside tool and the outside cut tool. As soon as I click accept on that position, you will see that the default safe cut area is represented on the screen. My router size is set to those odd numbers of millimeters. It must have converted from inches. As in the previous segment of video, you will have seen that you should set that to your router's maximum cut size. Note I say router as a generic term for a 3-axis milling device. You can use this with a Bridgeport or a Mazak or a Haas or an OpenBuilds Ox or a Shapeoko 2, 3 and whatever comes in the future, and so on. The software is written very generically so that it uses no fancy Gcodes whatsoever and will work on Gribble and TinyG as well as Linux CNC and Mac 3. The simplest cut of all is an outside cut, which offset the tool to the outside of the drawing, and there we have it. If we now generate the Gcode, we can preview it using the Plot Gcode tool, and we can see the tool will rise up to our safe height above the material, travel to the start point, plunge into the material, cut anti-clockwise around the material, and return to 0. In this software, XY00 is always at the bottom left of the material. There is no option to use the center of the material as 00. Also, one must be careful not to have the cut lines exceeding the boundary of the safe area. As you can see there, this left hand side and bottom are now outside of the safe area, and Gcode will not be correctly generated for those lines. In fact, some very odd things may well happen. Do not let your cut lines overlap the safe area lines. So what else can we do? We can cut internal shapes with the inside cut tool, which automatically puts the cut line on the inside of the shape. if we have a line across our object where we would like to cut, say, halfway through the material so that we can fold it at that point, we can use the fold tool. In the bottom right hand corner, there's the edit box for the percentage depth. That's percentage of material thickness. And you can use the left and right arrow keys for selecting different values, or you can type the value and press enter for a customized value. I'm going to select 50% and I'm going to select that line. Now notice it has shortened the line so that it does not intersect the outside of the object. This is to enable the outside cut tool to correctly function on that line. When we're cutting objects out of a flat sheet, we may want to prevent the cut object coming free and getting in the way of the cutter. So we can use the tab tool. In the parameters dialog, as a starting point, the tab width should be 3 times the bit diameter, because the way the code is generated, half the bit diameter is removed from each end of the tab. I've used the erase tool to erase just a tab in that case, and I'm going to place a new one right there. The tab tool works, of course, for inside cuts and outside cuts, and as you can see in the status bar at the bottom, there are some instructions. If you press the end button, you will toggle between V-tab and normal tabs. The cursor displaying a T is normal tab. V is obviously a V-tab. We'll place a V-tab there. In the case of a V-tab, the edges of the tab will not be a sharp up and down movement, but instead will be in the shape of a V, as you can see here. This saves time, but does make the tabs weaker, so you may need to adjust the depth by adjusting this percentage. In this case, 75% of the material is removed from the top and 25% is left behind. If I change that to a different value and regenerate the G-code, we will see the difference in the output. You can see the tabs are much deeper now and the sides of the V-tab are steeper. Circles are catered for. In two ways. An ordinary circle such as this one, which is still regarded by SketchUp as a complete arc, will be output as arc segments in the G-code using G2 or G3 G-codes. If, however, it is exploded, it will become separate line segments, which will be output in the G-code as separate line segments, making little flat spots on your object. Normally you have to explode it on purpose, but there are some editing operations where you split the circle and make it part of your drawing that can cause the segments to become regarded as plain line segments. You can see now that SketchUp has automatically split that arc into two segments, and I can delete it, but it is still regarded as an arc and will be cut using G2 or G3 codes. You can, of course, inside cut that, but instead I'm going to demonstrate the pocket tool. Again, in the bottom right hand corner, we can select the depth of the pocket, again using the arrow keys or typing a value and pressing enter. At this point, vertical zigzags are selected, and you can see in the bottom there are options for, you can see in the bottom here that there are options for the pocket tool. If you hold down shift, then you only get the zigzags. If you hold down control, you only get the outline, and if you press end, it will toggle the zigzag direction. Use the zigzag direction that is easiest on your machine. The reason for having separate, being able to separate the outline from the inside, is for complex objects like this. As you can see, there's a little blobs in the way it generates the zigzag, and so if you hold down shift, you get only the zigzag. It looks worse. If you hold down control, you get only the outline. Click. I can now draw a line from there to there. Reselect the pocket tool, hold down shift, zigzag that bit, zigzag that bit, and I can erase that extra line, and that pocket will now cut perfectly. The outline being one continuous tool motion and the two zigzags cutting before that normally. Let's look at the G-code for that. As you can see, start and end points are optimized to be the closest endpoint to the previous object, depending on the direction of cut. And so air motion time is minimized. So we've got pockets, we've got fold lines. What if we just have an arbitrary line on our model that we need a slot cut there, not all the way through possibly, but we need that slot cut. The tool for that is the centerline tool. Again, we can select percentage depth with the arrow keys or typing, and that makes a pale green line which will cut to that depth without having to be a closed loop like the outside and inside tool, or being a specific operation like the pocketing tool. This will not shorten the line as the fold tool does, and so you get exactly what you think you're getting. The next tool I want to look at is the plunge tool. This is for drilling holes. Holes can be either the bit diameter, larger than the bit diameter. They can be to the default cut depth or less. So let's draw just a plain hole of bit diameter. Just click, and there it is. That drawing there is a group, and groups are special to SketchUcam since they are cut first before anything that is not grouped, and the order of groups can be changed as well using the group reorder tool, which I'll show you just now. So let's now cut a hole 50% deep. Type 50, bottom right hand corner, press enter, click. As you can see, I've created a partial depth hole, and the drawing color is purple instead of a dark purple, and so you can tell the holes apart. If I now wish to drill a hole which is larger than the bit diameter, as you can see in the instructions in the status bar, press shift for a large hole. I hold down shift and click. I get a dialog requesting the diameter of the hole, and in this case I'm going to type 7. That will create a 7mm hole. I work all in millimeters. This is the world I live in. It works just as well in inches. As you can see, it has drawn that hole 7mm in diameter. And the color is dark brown, which indicates a full depth hole. If I want to do a partial depth large hole, as for doing a recess for a cap head screw, I can drill a hole all the way through, and then I can select a depth and a size. That will create a recess with a hole through the center for a cap head screw or similar. As you can see, I've done a partial depth large hole, and the color of the cut line has changed. Holes are a little bit special in that they do not like to have intersecting lines through the hole. That particular line will create some very odd things in the Gcode output. In fact, possibly drilling 2 holes. So don't do that. You can, however, do something like this and use that as the marker for a center for a hole. That will work just fine. It's when it intersects with this horizontal colored portion of the hole drawing that there is a problem. Let's preview our code that we have created so far. You can see these blue lines are plain holes. Let's just change this angle a bit. There's the first plain hole we drilled all the way through. This one is partial depth. This is the large hole, which comprises a drill down the center and then a spiral, a helical bore to achieve the correct size of 7mm. In the case of our pocketed hole, we have a central drill through the center and then a helical bore to 20% of depth for the pocket. Other tools on the toolbar are the erase tool. This tool will selectively erase either entire cut lines, parts of cut lines, as in if I select just a tab, it will select only the tab for deletion, or in the case of center lines, it will remove the cut from that line but leave the line there as geometry so that you can adjust it and apply the cut or whatever you need at a later time. For pockets, the delete tool is not the preferred tool, since the zigzags and the outlines are groups, and it's better to select the group, sorry, not group, they are curves. Just select the curve and press the delete key, and that will delete. You can also use the erase tool to erase those objects entirely. The next tool is the safe area tool. This allows you to move the safe area, which allows you to do multiple cut areas within one drawing file. For example, I could copy this item, paste it over here, and that safe area tool would allow me to position the safe area over there. And when I generate Gcode, it will only generate Gcode for this area and will ignore this area. Although you may notice group names in the Gcode output from this area. That is normal. By doing multi-drawings in that fashion, you can do a drawing with all the drilling on it, a drawing with a slot of a particular precise depth, and another drawing with all the outlines and whatever else you need. and you can combine them later using the Gcode joiner tool, which is accessed through this menu. All of these items are detailed in the help. Click the large question mark to go to the help. The help is in form of HTML files on your local hard drive. You do not require an internet connection to view these things. The front page of the help tells you what's new in each version. 1.3 has the major addition of ramping, commenting options, and a few other things to make it more Gribble friendly. The primary thing that you need to read through is this one, what the things are on the toolbar, how they work and what they do. And the other thing you want to have a close look at is changing default options. The options menu completely replaces the constants.rb and myconstants.rb mechanisms for selecting default options. You can now do it entirely from within the program through these various dialogues. Gcode is output to the default directory. The default output name is gcodeout.nc, or if you have already saved your file, the default output name will be the same as your saved SketchUp file. The extension is settable within the options menu and defaults to CNC. In my case, I prefer NC. And as you can see, the integrated Gcode previewer is quite happy with the new name. This icon takes you to the Flatboys homepage, which is flatforum.com. This toolbar is for the flat bones and is the subject of a separate video and a rather good help page, if I do say so myself. Just remember, the first thing you need to do is click the tool diameter icon before placing flat bones, just to make sure that you have the correct tool diameter, which must be slightly larger than your actual tool diameter, because you need a little bit of space for the cut lines to be offset inside your cut area.